Have you ever wondered what's inside a black hole? A question as vast and intriguing as the universe itself. Black holes, contrary to their name, aren't really holes at all. Instead, they are phenomenally dense regions in space, where gravity is so strong that absolutely nothing can escape its pull, not even light. Let's simplify this concept with an analogy. Imagine a whirlpool in a river. The water is being drawn towards the center so powerfully that anything caught in its path is pulled in too. That's a bit like a black hole's gravitational pull, but on a much, much larger scale. These cosmic whirlpools are hidden in the fabric of our universe, silent and invisible, yet holding secrets that could unlock our understanding of the cosmos. So as we stand on the threshold of this cosmic mystery, we can't help but ask, now wouldn't it be interesting to find out what's inside? Imagine standing on the edge of a cliff. That's what the event horizon of a black hole feels like. Picture this. You're on the precipice, peering over the edge into the unknown. That's the event horizon, the point of no return when you approach a black hole. Let's think of a black hole as a cosmic whirlpool. The event horizon is the boundary, the edge of this whirlpool. It's the point where the pull of the black hole becomes so strong that nothing, not even light, can escape its grasp. Now imagine you're a daring explorer standing right on this cliff edge, the event horizon. You decide to take one step forward to cross that boundary. What happens? You're pulled in, and there's no turning back. It's like falling off that cliff. Once you step over, you're in the black hole's clutches forever. But here's where things get really wild. You see, in the universe, time doesn't always behave the way we expect. Near a black hole, time starts to slow down. It's like everything is moving in slow motion. The closer you get to the black hole, the slower time moves. To someone watching from a safe distance, it would seem as though you're frozen in time at the event horizon, while you, the brave explorer, would feel time moving normally. It's a bizarre effect, and it's all because of the intense gravitational pull of the black hole. So, what's beyond the event horizon? That's the big question. It's a region of space we can't see or study directly because remember, nothing escapes a black hole, not even light. This makes it one of the most mysterious places in the universe. So, stepping into a black hole is a one-way trip, but what happens once we cross the event horizon? Well, that's a journey into the unknown, and we'll continue our cosmic adventure in the next scene. So, buckle up, fellow explorers. Our journey into the black hole is just getting started. Diving into a black hole is like sliding down an endless slide. Imagine yourself on a playground with the tallest slide you've ever seen. It's so tall that it seems to vanish into the sky. That's what it's like to fall into a black hole. You're on an unstoppable journey, sliding down a gravitational slide that pulls you in deeper and deeper. As you slide down, you might start to feel a bit stretched. This isn't your imagination. It's a real phenomenon known as spaghettification. Yes, you heard that right, spaghettification. It's a fun word for a not-so-fun experience. This is the process where an object, or in our case, you, gets stretched into long, thin shapes like a piece of spaghetti due to the intense gravity of a black hole. Let's break it down a bit. The term spaghettification comes from the word spaghetti, and it's used because it perfectly describes what happens. The gravitational pull of a black hole is so strong that it pulls more on the part of you that's closer and less on the part that's farther away. This difference in forces stretches you out, turning you into a long, thin strand of human spaghetti. However, don't worry, this is all hypothetical. Humans can't really survive a trip into a black hole, not least because of spaghettification. But it's an interesting concept to think about, isn't it? Black holes are fascinating. And the more we learn about them, the more we realize how much they can teach us about the universe. They're not just cosmic monsters devouring everything in their path. They're also cosmic laboratories, helping us test and understand the laws of physics in ways we couldn't otherwise. Sounds like a wild ride, doesn't it? But what's at the very center? At the center of a black hole is a place where all rules of space and time stop making sense. This is the singularity, the heart of a black hole. It's a point of infinite density, where the gravity is so strong that it pulls everything into it. Imagine you're standing on the edge of a colossal bottomless pit. You toss a pebble into it, expecting to hear a sound when it hits the bottom. But there's no sound. The pebble just keeps falling, deeper and deeper. That's because this pit is so deep that it has no bottom. This is a simple way to think about the singularity in a black hole. It's like a bottomless pit in space where everything, even light, gets swallowed up and can't escape. In this bottomless pit, all the mass of a black hole is squeezed into an incredibly tiny space. Believe it or not, if Earth were to become a black hole, it would be squeezed down to the size of a marble, yet it would retain its original mass. That's a lot of squeezing. In the singularity, space and time as we know them cease to exist. You might think of it as the ultimate magic trick, where things disappear and never reappear. But it's not magic. It's just physics at its most extreme, where our understanding of the universe is put to the ultimate test. The singularity is also a place where our current understanding of physics breaks down. The rules of Einstein's theory of general relativity, which describe the gravity, and quantum mechanics, which explain the smallest particles in the universe, seem to contradict each other. It's like trying to play chess and checkers on the same board at the same time. It just doesn't work. Scientists are still trying to figure out how to make these two theories play nicely with each other. They hope that by understanding the singularity, they can come up with a theory of everything, a single set of rules that can explain how everything in the universe works. So, the inside of a black hole is a place of extreme gravity and mystery. But could anything ever escape? What if I told you, black holes can evaporate over time? A surprising twist, isn't it? This is due to a fascinating phenomenon named after physicist Stephen Hawking, known as Hawking radiation. Imagine a party balloon, tightly filled with helium, floating joyously in the air. But over time you notice it starts to sink lower and lower. The balloon isn't as tight as it once was, it's losing helium, leaking out bit by bit. This is similar to how a black hole loses energy, albeit in a more cosmic and complex manner. Now let's dive into the science behind it. You see, space isn't completely empty. It's filled with what we call virtual particles. These are pairs of particles and antiparticles that pop into existence and then annihilate each other almost immediately. They usually go unnoticed, like a secret dance happening all around us. But near the event horizon of a black hole, something quite extraordinary happens. If one of these particles falls into the black hole while the other escapes, they can't annihilate each other. The escaping particle becomes real and flies off into the universe, carrying away a tiny bit of the black hole's energy. This is what we call Hawking radiation. Over incredibly long periods, these escaping particles cause the black hole to lose more and more energy, leading it to shrink. It's like our party balloon slowly deflating over time. This process is incredibly slow for large black holes. We're talking about timescales longer than the current age of the universe. But for smaller black holes, it could happen much faster. In the end, the black hole could completely evaporate, leaving nothing behind but a memory of its once mighty presence. It's a slow, gradual process, but it's a reminder that even the most powerful and mysterious objects in the universe don't last forever. So in a way, even black holes aren't forever. So, we've taken quite a journey today, haven't we? We've plunged into the depths of a black hole, exploring realms that are as fascinating as they are mysterious. Remember the event horizon? That's the point of no return where even light can't escape the black hole's pull. Next, we embarked on the fall, a descent into the unknown where time and space warp in unimaginable ways. Then, we reached the singularity, the heart of the black hole, where all its mass is concentrated into an infinitely small point. And how could we forget about Hawking radiation? This fascinating concept suggests that black holes can slowly lose energy and eventually, over trillions of years, evaporate entirely. Black holes are truly an enigma, a testament to the wonders of our universe. They remind us of how much we have yet to learn and explore. So the next time you look up at the night sky, remember, there's a lot more going on out there than meets the eye.